Hi, I am Nirutti Kasture. Today I'm going to talk about my research work that I have completed as part of the master's program I'm pursuing from Liverpool John Moores University in the field of machine learning and artificial intelligence. My research topic is investigation on generalizability of document image enhancement solution through multidimensional experiments. I've completed this research work with the guidance from LJMU professor Dr. Ahmed Kaki and under the supervision of my thesis supervisor, Dr. Rick Das. I will now show the structure of this presentation on the next slide. As part of the presentation today, I'm going to cover the agenda that you can see on the slide. I will start with the topic of background and explain the motivation behind conducting the research in this particular space, followed by the complete cycle that I followed to execute this research work. I will talk about the literature review that I have conducted and the problem statement that I have finalized. I will also talk about the aim, objective, and research questions that I have identified as a result of the literature review. I will talk about the research methodology in detail to explain why did I select this particular research methodology, and followed by the details on the implementation of this research method. The implementation aspect will cover exploratory data analysis, model building, model experimentation, and finally, I will discuss the results, conclusion, and make future recommendations for the researchers who want to develop more in this field. So let me now get into the details of the background and motivation behind this research. In 21st century, data is the new oil. It is today's reality and a fact because mankind is on a quest to digitize the world. As humans, we are always connected to the devices and technologies, and this has happened because of the rapid technology evolution and adoption in last few decades. We have become habitual to use laptops, mobile phones, internet, robots, and there are more inventions coming on the way, including 5G networks, uh, virtual and augmented reality, and many more. And one thing that is common in all of this is that all these technologies work with high volume of data. One of the prediction done by IDC in their report is global data sphere will grow to 175 zettabytes by 2025. Now, this is a huge increase considering the situation a few years ago. As a data driven world, the situation is continue to have more and more data, which is always available, which is being used and consumed rapidly. Now, this data generally is available in three formats. First, structured data, which is the traditional way of storing the information in Excel databases. The second way is semi-structured, which is more templatized, XML, JSON, and many more formats. And the third is unstructured data, which is stored in the form of images, documents, PDFs, videos. And this type of data is mostly not usable unless it is refined. Particularly the two type of data, semi-structured and unstructured, is quite interesting. It is almost contributing to 80% of the data availability in any large organization, and 20% is generally the traditional structured data that we use on a day-to-day basis. And that is where the organization sees an opportunity to refine and utilize this unstructured data because it is stored in the form of images, PDFs, or document, which is part of the day-to-day operations of any organization and part of their value chain. Organizations are increasingly applying intelligent document processing solution to extract information from these unstructured data sets from these documents to make sense of out of it and use it for subsequent activities. One of the research conducted by one of the market research firm states that the magnitude of IDP market is expected to reach US dollar 5.2 billion by 2027. Now, this claim does look realistic because of the amount of transactions done by organization using documents. Let me explain that through an example. Right? Here are few sample documents that a typical organization will use. That includes invoices, forms, bills, receipts, uh, heavy text documents like contracts, or maybe purchase orders, credit memos, and many other type of documents based on the domain the organization is working in. Now, these all documents are processed in high volume, and it requires a huge amount of human effort to process these documents and extract the right amount of information. Hence, the organizations are applying uh, the automated intelligent document processing solution to do the same work at a faster pace and at scale. But the problem happens when these documents are received in poor quality. And this happens because of the entire life cycle these documents follow, and also because of the original document quality. Generally, the documents may have a poor quality, or the documents are processed, stored in such a way where the external noise elements are included in the document, or because of overlapping text or handwritten content, the document quality degrades. And because of that, the automated intelligent processing solution is unable to extract the right information, and hence it decreases the efficiency of the IDP solution. Now, let me explain this in detail in next slide by talking more about the IDP workflow. Now, on the slide, you can see a generic workflow for an intelligent document processing solution. So, as part of the solution, the documents are collated and ingested into the IDP solution. After that, a pre-processing step is performed to improve the quality of the documents. Then the documents are classified into different categories based on the format, their layout, or the content. After that, the algorithm within the IDP solution extracts the data based on the features that are matching to the algorithm, followed by application of various rules depending on the specific domain. Now, in some cases, human validation is also required to confirm and validate the information that is extracted. Now, this is a generic workflow for any IDP solution, but there are nuances when the solution is implemented to a particular domain. For example, if the solution is implemented for a banking organization, they would have a different kind of forms and documents like KYC forms or various kind of applications that they need from the end customers. So the domain specific rules will differ from any other industry. If we take another example from energies and utility domain, there are bills, refund requests, and many other type of forms available, so the rules will differ for them. If it's look at the example of finance, there are invoices, purchase orders, credit memos, and many other type of documents, so the domain specific rule will differ, but each one of them have a common factor that they would receive the documents in the form of PDFs or scanned documents or images, and these documents may have some amount of degradation or noise element, and hence these require some amount of document processing. Now, in the current state, the solutions that are available in the industry, they are not effective enough to clean the document properly without impacting the extraction capability of the solution. Hence, I found this area interesting to pursue my research and build a solution that is able to clean the image, improve the document image quality, and at the same time, it is helping to improve the text extraction capability of the solution. So now let me get into the details of the research, and let me first explain about the overall program structure that I have followed to conduct this research. So here is the overall structure of this research program. I've completed this research over a period of 6 months with 4 key milestones. So after completing the research topic submission, I've started with literature review, and as a result of that, I have finalized the problem statement, aim, and objective of this research work. I've also identified a few research questions to investigate as part of this work. The literature review was also conducted to understand the work done by the previous researchers, the solutions they have built, and any kind of gaps and limitations that I could find out as part of the literature review in those research work. As a result of this review, I've also finalized the research methodology, followed by the implementation of this research method through a structured approach. I have completed the exploratory data analysis, data processing, augmentation, model implementation, evaluation, and finally, discussing the results as part of my research report. I've also included the conclusion and recommendations for future work as well. Now, in the subsequent slide, I will talk about each of these topics in detail, starting with the literature review. So let me move to the next slide and start with the literature review section. As part of the literature review, I have reviewed 75 different research papers and journals and found that the solution in the space of document image enhancement have been developed over 30 plus years, starting with early stage solution in the years of 1980s, where the researchers followed a primitive approach of using threshold values that included global threshold, adaptive threshold, and energy functions. Now, these research work and solutions were very basic, and they needed manual configuration of threshold values. And one of the gap that was noticed that these solutions were not generalized for a different variety of document formats. Now, after that, for a decade, there was a period of AI winter. In that period, not much progress happened in the field of artificial intelligence itself. But the work again ignited after the inception of convolutional neural network, and particularly from the year of 2019, there have been significant number of researchers who have used convolutional neural networks and generative adversarial networks to build different kind of solutions to improve the document image enhancement solution. If I name few of them, they are here on the slide as well. So our researchers have used a full convolutional network, unit-based architecture, and they have also applied pre-trained model and transfer learning. Some of the researchers have used standard GAN, cycle GAN, conditional GAN, and DC GAN as well. Now, along with that, some researchers have used transformer-based model starting 2021 to improve the quality of natural images. The work was primarily focused on natural images, then the document images. A few examples are Swin transformer or IPT. There have not been much work with the use of vision transformer, but one of the common factor that was found in all this research work that the generalizability of these solutions was missing because of few reasons. Number one, many of these researchers have relied on the historical document data sets, particularly DIBCO and Palmleaf. And these solutions were not tested on different kind of document formats, which are more contemporary, such as invoices or KYC forms or the purchase order receipts, the documents that are more useful in industry and organization. Second, in many of these research works, the researchers have selected only one or two types of degradations or noises to address the problem. They have not really tested the solution on variety of challenges that a document faces. And third, the evaluation matrices that were used to test the performance of these models, they were focusing on improving the document image quality. They have not really tested the solution to see the impact in terms of the text extraction capability. Now, considering these gaps, I have framed the problem statements and objective, which I will talk about in the subsequent slide. But one of the pattern that was found that transformers, which are very effective in solving NLP and computer vision tasks, they have not been fully explored for document image enhancement challenges. So I have selected Vision Transformer as a research methodology to apply as part of this research, and also implemented the same using the Python libraries, and I will talk about those in subsequent slide. Now, based on the detailed literature review, I have finalized the aim is to investigate generalizability of the solution to cater to multitude of document formats without decreasing the text extraction capability. Now, to achieve this aim, I've also finalized four objectives, which are as follows. The first one is to investigate the generalizability of one of the existing solution and find out if the solution is able to cater to different kind of formats. Number two was focusing on adding more document formats as part of the training process using different training methods such as cross format or leave one out. Third is to investigate the impact of combining multiple documents data sets and validating the performance of the developed model. And four, identifying the impact on the text extraction capability of one of the OCR or text recognizer solution as a result of applying this document image enhancement solution. So these four objectives that I have finalized for this research work, and I will discuss about the results against these objectives at the end of this presentation. Now let me explain the research methodology that I have selected for this research work. So based on the research literature review, I've selected vision transformer based model to implement this solution. Now transformers were introduced to handle the situation and issues within the space of NLP. But the self-attention feature of these transformer solutions have helped to handle various type of computer vision tasks, and hence they have been very helpful to handle object detection and segmentation type of work within computer vision space. However, they have not been explored fully for document image enhancement solution. So now in this research, I'm going to use this method and explain the overall architecture that I've followed to implement the vision transformer based solution. So as a first step, the input image, which is the degraded image, is split into multiple patches based on the fixed patch size. And these patches are flattened and inserted into a linear projection layer to convert into various tokens. Now, these tokens, they are embedded with positional embedding information and then fed into a transformer encoder layer. Now, this encoder is a combination of multiple transformer blocks that includes multi-headed self-attention layer and also a multi-layer perceptron. And this entire encoder layer uh, converts this token into a latent projection. All these tokens are then fed into another layer of transformer, which is the decoder construct. And from there, the decoder also helps to calculate the loss between the input degraded image and also the cleaned version, the ground truth image that was fed into the decoder layer, and calculates the mean squared error loss. And based on this calculation of loss, the model parameters are updated to correct the training state of the model, and also then uh, generate the cleaned version of the degraded image. As you can see on the screen, this entire flow from submitting the degraded image to generating the clean version of image has two primary components, encoder and decoder, and both of them are implementation of vision transformer. So I will talk about the implementation of the vision transformer model in subsequent slide, and also explain the entire flow that I have followed to implement this solution. Now, before beginning the implementation of the solution using vision transformer based model, I have focused on gathering the right type of data sets, because one of the challenge that I've highlighted from past researches is that researchers have relied on historical documents to use for their researches, which is one of the limitation and also indicates the solutions were not generalized. So to address this gap, I have used 5 different type of data sets, which contains different kind of formats and dimensions. And these data sets are analyzed through a structured approach, which I will explain now, starting with the data understanding as a first step. Now, all these 5 data sets have large number of files available. Uh, some of these data sets have paired files, and these paired files contains degraded as well as the ground truth images. But 3 of these data sets only have ground truth images. So this also confirms the need to do the augmentation of degraded and noisy files in these data sets before building the model. So from these data sets, I have selected close to 500 document images with 3 distinct formats in terms of PNG, JPEG, and TIFF files. And I have used that to build the initial data set. Now, this initial data set is analyzed through an structured approach, and I've conducted the initial exploratory data analysis to review the structure, content, and quality of these document images. To verify the structure of these images and to investigate the diversity of dimension in these data sets, I have calculated the aspect ratio of various type of document images from each of these data sets. And what I found that among the data set, there is definitely wide variety of images available with different kind of dimensions and aspect ratios. However, 2 data sets, Dipko and Sarohi, have uniformity in terms of their aspect ratio. The second analysis is conducted using histogram plots on the pixel intensity distribution of these images that I have collated in the beginning. And this is done to confirm the distribution of pixel in a particular document image. And based on the results of this analysis, it was confirmed that there is a need to augment more degraded images because 3 of the data sets do not have presence of degraded images. They only have ground truth images available, which are clean version of images. Third, I have looked at the quality parameters and performed analysis on these document images with 2 different methods. And the reason to adopt these 2 different methods because the 5 data sets have paired as well as unpaired images. So the paired images where degraded as well as ground truth images are available, I have used SSIM, structure similarity index measure, to calculate the image quality score. Now, this method, of course, requires a pair of images, and hence it was applied on those data sets where there is a pair available. Now, the other scenario where the 3 data sets did not have a paired set of images, I have used another reference-less method, which is called BRISC, to calculate the image quality score. And based on these 2 assessments, it was confirmed that the 5 data sets in total have considerable amount of degradation and noise. However, some of the data sets are lacking the noise elements, and that needs to be augmented as part of the subsequent step. As a next step, I have performed some amount of processing in these data sets to convert these files into same format. So as I mentioned earlier, the file formats are having 3 different extension: PNG, JPEG, and TIFF, and this could add complexity while building the model, and hence it is important to bring all these files into same format, and that's what I have completed as part of this step. As a next step, I have performed augmentation of degraded and noisy images for all those data sets wherever degraded quality images were missing. And this was done with inclusion of 4 additional type of noise and degradation. Particularly, I have applied salt and pepper noise. Then I've also applied erosion and dilation on one of the data set. And third, I have included overlapping text on the invoice documents from RVL CDIP data set. Now, this entire augmentation is done to make sure that I'm considering different kind of degradation and noises as part of this research work. Now, this is one of the gap that I have noticed in previous research work, that the past researchers have only targeted one or two type of noise elements or degradation as part of their research work. With this augmentation, I am targeting 7 different type of degradations and noise elements. And as a result of this entire augmentation activity, the total dataset size has become 652 images, and they are structured into 16 different directories. Now, after completing the augmentation, once again, I have run the assessment using SSIM evaluation metrics to reconfirm that the augmentation has really helped to improve the diversity of the data set in terms of including the degradation and noise element. Now let me move and forward and explain the implementation of this model using the data set that I have collated. Now, after completing the entire cycle of data preparation, I have followed the sequence of activities shown on the slide to complete the model training. Now, this image on the screen shows the entire set of activities followed as part of one epoch, one iteration. And there are numerous number of iterations conducted as part of the experimentation that I will talk in separate slide. But here on this slide, the first step is the data loading, where I have loaded the training and validation set, which was prepared as part of the previous activity I have explained earlier. Now, this entire data set goes through a linear transformation and the application of self-attention mechanism from the vision transformer as part of the forward pass step. On top of this, the loss calculation is done using the mean squared loss function, and this is done between the degraded and ground truth images. And based on the loss value calculated, the model parameters are updated as part of the backward propagation. Followed by this, the validation is performed on the model performance using the validation set, which was uploaded in the beginning, and the PSNR values are calculated. Now, PSNR is one of the evaluation metrics that I have used, and this is to assess the uh, impact in the image quality based on the model training. And as I mentioned earlier, multiple epochs of these trainings are run, and the best PSNR score generated by a particular epoch is stored as a checkpoint to make sure that the best performing model is stored for further validation and testing. Now, after completing the model training, I have conducted multiple type of experiments to assess the model performance. And these experiments are primarily divided into 4 categories. The first one is the use of pre-trained weights from one of the previous implementation done by another researcher. Second category focuses on using cross-format training with additional dataset augmentation. Third category is to augment additional dataset and leave only one dataset for validation and testing purpose. And finally, the fourth category uses a union of all datasets, and the testing and validation is done on a sample of unseen images from the same dataset. Now, these 4 categories were explored through 7 different experiments that you can see in the table shown on the slide. Uh, so the experiment 1 through 7 uses different kind of image sizes, batch sizes, number of epochs, and dataset combination. Now, one of the common factor that I have maintained is to use the batch size of 32, considering the computational capacity available with me to conduct all these experiments. However, as part of these 7 experiments, different kind of variations were brought in terms of modifying the image size, patch size, number of epochs, and the data set. So the first experiment, which caters to the category 1, used one of the pre-trained weights from previous implementation, and the testing was done on the DIPCO 2011 and the training was done on the DIPCO 2011 dataset, and the testing was done on the denoising dirty document dataset. Experiment 2 and 3 belong to the category 2, and in this case, I have augmented more data sets to improve the quality of the model that was implemented, and this was tested using different type of validation and test data set. So in case of experiment 2, I have used partial DIPCO data set, the denoising dirty document, and the forms data set as a training data set, and then DIPCO 2016 and 2018 data sets were used as validation and test data set. Similar approach was followed for experiment 3 as well. Now, in case of experiment 4, which belongs to category 3, I have used majority of the data sets for the training purpose and only kept the DIPCO 2013 and 2017 data sets as the testing and validation data set. From experiment 5, 6, and 7, I have used majority of the data set as a union of data set and also experimented with epoch size and also with patch sizes. Now in these experiments, I have combined all the data sets, and during the testing and validation stage, I have used a sample of unseen images from the same data sets. Now, the results of these experiments are collected in terms of the model performance on various different evaluation methods, which includes qualitative and quantitative measurement both. And I will explain that in the subsequent slide. Now, this research is focused on multidimensional experiments to investigate the generalizability of document image enhancement solution. And throughout this research, I have attempted to use multiple different dimension and angles to execute every step. So as I explained in the previous steps, I have used 5 different type of data sets, different kind of degradations, and also performed 7 different experiments. The same approach continued with the evaluation of model performance. And I have applied 5 different type of evaluation matrices to assess the model performance. Starting with the first uh, evaluation metrics, which is the PSNR value. So PSNR is peak signal to noise ratio. It is one of the common metric used to calculate the image versus the noise element ratio in a given input image. Now, this particular metric is applied during the training and testing cycle of every experiment. And as you can see in the table on the left, each experiment have shown different kind of PSNR values. Now, in some cases, the testing PSNR is significantly lesser than the training PSNR, and this is because of the problem of overfitting that happened in the particular experiment. Now, this overfitting indicates that the model is able to perform well on the training data set, but it is unable to do well on the testing data set. And this was addressed by adding more data in the subsequent steps. As a result of these experiments, the experiment 7 has shown the highest and stable values between training and testing PSNR. And PSNR as a metric, if it has higher value, it indicates the higher performance and higher image quality. Now, this evaluation metric was supported by another performance evaluation using the SSIM score, and this metric I have used earlier as well in the analysis phase. Now, SSIM scores are calculated for a sample set of images generated as part of every experiment, and in this analysis, I have used a combination of ground truth as well as the cleaned version of images. So if you look at the table on the right, experiment 1, as it was tested only on one data set, the values are shown on this screen, and this became the baseline value to compare the rest of the experiment. Now, as part of experiment 2, 3, and 4, two data sets were tested and validated, and their SSIM scores are shown here. And the numbers indicate that the performance of the model on this particular metric is better than the experiment conducted using the pre-trained weights in the experiment 1. Now in experiment 5, 6, and 7, I've used all type of data sets and then tested it using a mix of sample images from the same data set. And hence the results are available for all the data sets. And each of these experiments are showing significantly better results compared to the previous four experiments. And finally, the seventh experiment shows the greatest amount of improvement in terms of the similarity score for the predicted images. And hence, both of these evaluation metrics shows the experiment 7 model is performing better than um, the other experiment models. Now the experiment evaluation continued with another evaluation metric, and I've used the histogram plots here to review the pixel intensity distribution of the input degraded image and the cleaned version of image which was received as an output after completing the experiment. The image that you see on the screen it's a histogram plot of a sample image, and on this graph, the x-axis shows the different pixel values, and y-axis shows the frequency of those pixel values in the input image. So the left side of images shows the plot for the degraded images, and on the right it shows a more cleaner version of the images in terms of the pixel intensity plot. And this intensity distribution confirms that the images are indeed getting cleaned using the various models. After this, I have used a visual comparison method, which is a qualitative evaluation of the input and output images. On the slide, I have included some of the sample images from different data sets. And visually, it is evident that the model is able to clean the noise elements from the input images, and it is able to preserve the text element, the foreground pixels of these images very well. The same approach continued with another evaluation on the text extraction capability of this model performance, and I will explain that in the next slide. Now, one of the objective of this research was to investigate the impact on the text extraction capability of an OCR engine or a text recognizer solution as a result of applying the image enhancement solution. What you see on the screen are the results of the OCR experiment that I have conducted as part of some of the experiment. And given some of the data sets do not have text in English language and also has a complex styled fonts, I have not been able to conduct the experiment for all the type of data sets. However, the experiments were conducted for all those data sets where English text is present. And hence, there are results shown only for the four experiments. The OCR test is conducted using the TestRect OCR engine, using the PyText TestRect library from Python. And it is conducted on two type of text documents. The first type is having a high amount of text content, and the second type of document is having text along with tabular structure. Now, these are two common scenarios found in any organization. Hence, these two were selected to perform the test. The table on the screen shows the scores of character accuracy, word accuracy, character error rate, and word error rate. Now, these are important matrices to assess the impact of text extraction from any document images. And as it is visible from the table that the experiment 3 had shown poor results. Now, this is because of the model performance on the document images. While it is able to clean the image, it is impacting the quality of text extraction. But experiment 5 onwards, the results have improved, and experiment shows the significant amount of improvement in terms of accuracy and reducing the error rate. Now, this experiment and also the experiments and evaluation explained in the previous slide concludes the overall performance analysis of the model that I have created as part of this research work. And as a result of all this experiment, it is visible that experiment 7 shows the greatest amount of improvement and shows the best performance among all the experiments that I have conducted. Now, let me conclude the results with respect to the objectives that I had listed in the beginning of this research. So what you see on the right side of this slide are the four objectives that I had mentioned in the beginning of this presentation, and as well as I have listed as part of this research work. So the first objective was to assess the generalizability of existing solution. Now, through experiment one, it is assessed that existing solution, which is used in this research work, is unable to generalize on different kind of document formats. The second objective was to assess the application of various training methods, which included cross format and leave one out training format, and analyze the effect of these different training methods in terms of generalizability. Now, this is conducted through experiment 2, 3, and 4 that I have explained in the previous slide. And the result shows through some of the evaluation matrices that the performance of the model has improved compared to the baseline value. However, the results are not impactful in terms of the text extraction capability. The third objective is about the union of data sets that I have applied during the experimentation process, and to assess the impact of these combination of data sets. Now, these experiments were conducted through experiment 5, 6, and 7. And as I have concluded previously, experiment 7 shows the best result, as well as it is helping to fulfill the objective 4, which is about extracting the text from these document images and assessing the impact on the text extraction as a result of applying the model. So objective 3 and 4 have shown the best performance as a result of the experiment 7 model. So as a conclusion, I would like to mention that use of different kind of data sets, use of different kind of degradations have definitely helped to improve the model performance, and hence this model has worked better than the previous work that was done by various researchers. Now let me summarize this entire research work and the process that I've explained in the previous slide through various facts and numbers that I have gathered through this research work. Now, on this slide, I would like to summarize the overall research work that I have done and explained in the previous slide. On this slide, various facts that I've explained in the previous slide are summarized here. So I've started this research work with the review of 75 different research papers, and then finalized 4 objectives to conduct this research work. I have collated 5 different data sets to make sure that the model that is being built is using different kind of formats, and also using the data sets that are more contemporary and useful for the industry application. The data sets had 3 different kind of files, JPEG, PNG, and TIFF format. And with data augmentation, I have used 7 different type of degradations to make sure the model is exposed to various kind of challenges which are more relevant from an industry application perspective. Initially, I had 492 files as input data. However, with the data augmentation, the data size increased to 652. And all these images had different kind of dimensions and aspect ratios. Now, these images were fed into the model as part of the training cycle with image size of 256 and 512. And the patch sizes that I have used are in 2 categories, size 8 and size 16. And the epochs were run for 10 and 20 iterations in different experiments. That experiments that I have conducted belong to 4 different categories, and I have executed 7 different experiments to look at the model performance from different angles. And this is measured through 5 different evaluation matrices. And the results are shown here in terms of the best results that are captured from the experiment 7 for the PSNR, SSIM, and the text extraction matrices that I have evaluated. So now let me explain the conclusion and the future recommendation of this research work. Now on this slide, I would like to talk about the conclusions of this research work. There are 4 conclusions that I have made based on this research. The first, The existing model weights that are trained using a particular data set of historical document is unable to generalize on unseen document images, and hence it is not useful in the commercial and industry use. Second, augmentation of additional data set is helping to improve performance to some extent. It is helping to improve the image quality, but it is unable to improve the text extraction capability. Third, introduction of additional noise and degradation, and also applying a combination of diverse data sets have helped to significantly improve the document image quality, as well as improve the text extraction capability. As a future recommendation, I would like to suggest to validate the performance of these models on private data sets that may belong to a particular organization, and future researchers can consider this by getting the required approval to use the private data set and validate the performance. Second, the solution can be further enhanced by adding more data sets and more degradation. Third, while I have trained the model with up to 20 epochs based on the computational capacity available, future researchers can look at training the model or with more epochs if they have more capacity and resources available. And finally, this entire research work has used a supervised learning method. Future researchers can consider application of unsupervised methods and assess the impact or improvement in terms of the document image solution capability. With this, I would like to conclude my presentation and thank Dr. Ahmed Kaki from LJMU, Dr. Rick Das, my thesis supervisor, Dr. Sahil Sharma, who has been the course mentor throughout this program, for their efforts, mentoring and guidance throughout this research program. I would also like to thank LJMU for this opportunity to present my thesis work today. And I would like to thank the Upgrade team for their support during this entire program. Thank you and have a great day ahead.